Okay, if we turn to page 8, what we're going to go over now is we've learned that when we graph systems of linear equations, we can end up with 3 possible scenarios. First is we have intersecting lines, so we have one solution. Second is we have parallel lines, so we have no solution. And the third is one line is coinciding with the other, and we get infinitely many solutions. Okay, now we've solved many that had one solution, so we're not going to consider that right now. But what does it look like? We know what it looks like when you graph. So here, if we say y equals 2x plus 1, y equals 2x minus 3, we can see that these are parallel lines. We know they're not going to have any solution. We could graph them and they might look like this and we'd see no solution. But what would it look like if they were given to us like this and we were just told to solve? Well, if you're just told to solve them, you'd probably try to solve through elimination. I would look at this and say, okay, I'm going to multiply this whole top equation by -1. So I get 2x minus y equals -1. When I go to eliminate my x's, I realize my y's eliminate too. And I end up with this type of solution where the variable disappears and it's a false statement. So I would end up with 0 equals -4, which is false. And since that's a false statement, there's no solution. Okay, now let's think about what it would look like if it was infinitely many solutions. So if you turn to page 9, you see we have x plus 3y equals -3, 3x plus 9y equals -9. And if I just went to solve this instead of graphing it, I might say, oh, I'll multiply the top equation by -3. And what happens when I multiply the top equation by -3? I end up with -3x minus 9y equals 9. And this is 3x plus 9y equals -9. When I add them together, everything eliminates, and I end up with 0 equals 0. Well, 0 equals 0 is true. So if you end up with a true statement, that means there's infinitely many solutions, because the only way you'd end up with 0 equals 0 if you subtracted the same equation from itself. So when you end up with no solution, variables disappear and it's false. When you end up with infinitely many solutions, variables disappear, but it's true. So let's look at page 10. And I want everyone to try checkpoint number 1 and checkpoint number 2. Turn the video off while you do it and turn it back on when you're done. So you're doing checkpoint number 1 and 2 on page 10. So for number 1, we have y equals 2x minus 7, 4x minus 2y equals 14. I'm going to line these up. -2x plus y equals -7. 4x minus 2y equals 14. I'm going to multiply the top by 2. I get -4x plus 2y equals -14. And I end up with 0 equals 0, which is true. So it's infinitely many solutions. We'll compare that to number 2, which is 2y equals 8x plus 4, -4x plus y equals 4. I'm going to line them up by subtracting 8x from both sides. And I'm going to multiply the top by -2. So I get positive 8x minus 2y equals -8. And we end up with 0 equals -4, which is false. So that is a no solution. Okay, now If we look at the bottom of this page, there will be vocabulary on your quizzes and tests. And the bottom of page 10 is very helpful. Now, first, you see lines that intersect. Lines that intersect have one solution. So the lines intersect. Describe the slope of the line. Different slopes. Okay? This describes the lines. Now, let's describe the system. This system is consistent because there's at least one answer. Independent because they go in different directions. So this is a consistent, independent system. If you didn't already copy this down from the first video, you should copy it down now. Then we have parallel lines. So these lines are parallel. When I describe parallel lines, they have same slope, but a different y-intercept. When I describe the system, I call this an inconsistent system. It's inconsistent because there's no solution. Final scenario is coinciding lines. So these lines coincide. How do I describe coinciding lines? Same slope, same y-intercept. And we call this consistent dependent because they don't have a choice where they go. They have to go in the same direction system. So notice we use different vocabulary to describe a system versus vocabulary we use to describe lines, such as slope and y-intercept. Okay, so now turn to page 11. Read the little review and do problems 1, 2, 3 on your own. Stop the video and do them on your own. I will provide the answers. So number 1, these intersect, there's one solution. Notice they have intersecting lines, different slopes, one solution. This is a consistent, independent system. Number 2, no solution. No solution because these are parallel lines. They have the same slope, different y-intercept, and it's an inconsistent system. Number 3, infinitely many solutions. Why? Because it's the same line, coinciding lines, same slope, same y-intercept, and we call this a consistent, dependent system.